Hello and welcome to Doing More with Time Series Visualizations in Kibana. I'm Graham and I'll be walking you through your agenda today. We're going to be talking a lot about time series visualization, focusing on the tools of time in Kibana with live examples and demos throughout. Um, we'll end with some resources and takeaways in the form of a PDF with some links on it. So feel free to take those and we'll be taking your questions throughout the entire presentation. Definitely encourage, if you haven't yet, or if you'd like to spend this time to get it ready, try this out while we're going through things. So open up your cluster, log into Elastic. If you don't have that already, you can actually try Elastic Cloud for 14 days with no credit card. You can also download free and open Elastic on your laptop or server right now. The version we'll be using today is 7.15, which came out just a few days ago, a week ago. So there might be a couple new things here, but most of these features are available for many of the prior versions that we're going to be looking at. Also, if you're not sure or you're unfamiliar with Kibana, as I'm doing the demos, the place to look is this breadcrumbs in the upper left-hand corner. This will help you know where I am. And this lines up, like this dashboard tab, lines up with the options available in this hamburger menu. So very easy to pause the video or take note of where I am and jump in there. And like I mentioned, ask questions in the chat or in the Q&A function on the meeting. And if you think of something later, hit us up on the discuss forum. So no good talk is complete without just a little bit of theory. So why is time series visualization really, really important? It comes down, for me personally, is it's one of two superpowers that we have as data analysts. Time series data, time data, is a way to join any number of data sets together to draw some interesting conclusions. And you can join and correlate any two data sets together that you want. This is a really powerful capability to help determine root cause. The other superpower is space. And while this talk isn't focused on maps and the things you can do there, that is another very similar analog as time, in that you can layer any data you want based on location or based on time to start to draw conclusions. And this is a really, really powerful capability. Time series data also is a natural ordering. It's very natural in that we experience time right now and always for our entire lives. And this gives the design of a time series visualization a strength and efficiency found in no other graphical arrangement. It's something to the order of 70% of data visualizations are time series. So everyone is really familiar. We live and breathe time series data in our lives. We live and breathe time. So it's a very great place to do an analysis. Also, when looking at a number or a metric, it's hard to tell if something's good or bad, right? So time series data gives us the ability to look at the same metric back in time. So you're only comparing yourself to yourself back in time and draw maybe some conclusions or some comparisons to how things are moving. So that's just a little bit of theory, but always good to kind of ground where we are. We're going to be spending most of today talking about the tools of time in Kibana. And I've organized these tools into 3 different groupings of time series analysis. And yes, I'm going to get this out of the way. You're going to see a lot of lines and area of visualizations, like as a data visualization choice. So we're going to focus on the tools and metrics and analysis that go into those lines, and not as much about the visualization choices themselves. There are other talks in Elasticon you should check out for data visualization best practices. In each of these groups, we're going to answer different questions. And the first grouping is the simple tools, which are good, just like a measuring tape or a level, in that they're commonly used and really, really useful to help determine things like, how's my data flowing in and what's the behavior of my data. The next group I've been calling precision tools, in that they can answer a little bit more precise, like cameras or shovels. They require some foresight and planning, but they can help determine things like efficiency, help solve for tricky data. We'll look a little bit of that in the demos. Compare and contrast the past and present at the same time, which is really, really cool functionality that helps you, get to one number, and can be useful to help the beginnings of understanding root causes and start to draw some conclusions across data sets. We're going to end then with the power tools. These are the most complicated tools to use. Maybe you should read the manual a little bit, but they can also do some really cool things, like help determine when something unexpected has happened. So rather than having to look through all of your data, have the data speak to you directly, and help understand the relationship between different data sets. One note is of everything I'm going to show today, there's only one feature that isn't available free and open, and it's some of our machine learning functionality here in this final demo. So I'll call it out specifically, but everything we're looking at is in our basic license and available for you to try for free forever. And that's awesome. So hopefully you take advantage of that. So let's jump into that first category. We're going to, get familiar with my data. In this case, I've used some interesting data, so hopefully it's interesting to you as well. We're going to visualize that data, look at how you can quickly become really familiar in the data visualizer. Then we're going to build some basic time series analysis of that data. And then we're going to play with the different ways you can aggregate that data in two different varieties here. So I'm going to jump into a demo and we're going to get familiar with my data right now. So if you're logging into Kibana for the first time, a little caveat. I'm going to be using mostly data coming from an information system, metric and log data coming out of a system like a data center somewhere, really tiny one because demo, but it's there. If you have data like this and your data matches one of these use cases, these solutions, enterprise search, observability data, which my data does, or security, it can be really good to start your analysis in the solutions because these are out of the box, purpose-built time series analysis. So if I, for example, click over to observability data, I can look at a given host in my little tiny data center called Frank, they've given them really cute names. And I see a wealth of metric information trended over time for all the different types of data that I have. This little data center is running Kubernetes, so I have metrics from that. I have some Nginx request rates and different other things that are coming in. I'm not going to spend a lot of time in the solutions because there's great other talks for that, but it's a good first place to start if your data matches these solutions use cases. I'm going to spend a lot of time in this analytics section because I can't assume your data is going to fit that mark. And also it's you can kind of see the primitives and all the forms of data analysis we can do over here. So in the analytics section, just to kind of show you the data, the first place I'm going to go is either Discover or the machine learning data visualizer. And the data visualizer in machine learning is available in our basic license. And it's really, really cool. We're actually working on features to integrate this into Discover as well, because this is the ultimate way to get a lot of context about a data set. So here we have the first time series of the day. And this is my metric data, one of the two data sets coming from my time series data. And you can see something pretty unusual happening here in this histogram in that we're seeing very consistent numbers of records coming from metric data. And this is an important thing to know. When we use metric data, we're actually sampling a system and we're asking it periodically, what is your current values? And then we're storing those current values. And what this means is the count of data coming from my metrics is actually going to be consistent because we're just sampling every 30 seconds or something and getting a reading on everything. And this is good to know because that means my count of records doesn't reflect human or computer behavior. It's just reflecting the design of how we're gathering metrics. The other cool thing you can do here is look at all the different fields in the data. You can see what the values are, and you can also filter for different types of data like number data. This is really useful because we can know what normal is for this data set. You can see these distribution of values, and you can see basically where the data sets trend towards, so that when you start analyzing your data in time, you're able to understand if it's doing more or below normal. So use this. I call it the Context Builder 3000. That's not a marketing name. That's just my name. It gives you a lot of context on your data. Let's flip over to the same view, but for a different data set coming from our log data from the same system. So different than different than metrics, logs are reflecting of a system or human behavior. And so the counts are actually a lot more interesting in that regard because more of them means more of something is happening. And so this gives me a little bit of understanding of the overall layout of my data. Finally, if you're looking to get a little more context and actually see the data, I'm going to head over to Discover, again, using the navigation. If you're not clicking around like I am, it's just right there in the menu. And here I can actually see the data, see the time things occurred, and see the different, that same histogram of counts up here at the top. And this, again, shows me that this is how my metric data performs. Okay, so we've got our context now. We've got metric data, we've got log data. Let's visualize some of it. And to do that, I'm going to go into a dashboard. I'm going to click down to dashboard. So click create visualization. And here I see at the top left, I can pick my different data sets. So I'm looking at my index pattern for metric data. And let's start by looking at, I'm going to look at my IO weight percentage. So this is a CPU metric. And if I just drag it out, you'll notice I get an immediate time series visualization of that data. Since this is a percent, I can do things like editing the value format to be a percentage, and I can look at it. Now, a median for data like this is not as granular, doesn't show me as much variation in the data because I'm only seeing the middle value for the time period, the 30 seconds that are being displayed. So you might want to start messing with the aggregations here. Switching to an average will give you a very different story because now we're actually averaging all those values. Another thing I really like to do with time series data is switch to a line visualization so that you get that continuous flow of data there. The other thing you can do is change to, let's say your data is pretty flat. This data actually isn't, which is kind of cool. I wasn't expecting that. Kind of every demo is different. But if your data is pretty flat or you don't care as much about the bottom of the data set, like you just want to see high values, you can use the percentile aggregation to basically eliminate the bottom, in this case, 95% of data, and just look at the top 5% and how that top value is changing. And here we can see we're actually exceeding 100% because there's multiple machines, but we can see how the system is exhibiting load and how this metric is changing in time. The final thing you can do just as like a tool, and I'll give you some caveats with this one, is you can play with the bounds of how the data is arranged on the axis. This will distort your data. It's always recommended to have 0 in the picture, but if the data is moving very subtly and those subtle movements matter, using data bounds will help zoom in on the data set. This, like I said, can distort the picture and lead to some misleading judgments. So only use this if it makes sense for your data set. But playing with the scales here can help. Maybe you see something that you didn't. And another good trick is to play with how many buckets are being displayed, how many intervals of time. By default, we're going to balance performance against how much granularity you need, but you can always turn on this customized time interval and bump this number down to like 5 seconds, and you'll get more points, and it might tell you a different story. This does come at a performance cost, so weigh that resolution of the data set against everything else to see what makes the most sense for you. All right, so that was our first kind of familiarity. Let's move into those more precision tools now. So let's look at that log data in the next example, and we're going to look at the composition of logs using something like a ratio. The reason the composition can be important is it might not matter that you get more of a certain thing if you're getting more data overall. So a ratio can help kind of see the percentage of data and how that's changing. And if you're getting more errors as a percent of total, for example. We're going to look at measuring changes with efficiency by dividing per a specific unit with formula. And we're going to be looking at how to do the past and the present at the same time with a time shift. And then finally, we're going to look at ways you can cross-filter this data and do multiple metrics of analysis at once in a dashboard. So let's jump back into a demo. So the first thing I want to show you here is that ratio idea. So for that, I'm going to flip over. Let's reset all this, which you can do with this little eraser. And I'm going to change from that metric data to that log data that's coming. Because again, that log data reflects behavior. So it's a little bit more interesting in this case. So if we have a count of logs, just trending the basic how many we have, I'm going to put 0 back on the map because I think the distortion is a little distracting here. So we can see kind of all the way 0 to 1,000 logs in a minute. I might want to filter this for just my error logs. And so I can actually come down to this advanced option and enter any search term, any KQL or Lucene syntax, and filter to just my error logs. And this is this question, right? Is 6 error logs a lot, or did I just get more data and I'm erroring at kind of a normal rate? And so a ratio can really help us answer this question. To do that, I'm going to click my error filtered count over to formula. And you can see I have a count of my errors. And what I want to do is see how my count of errors is as an overall total from a count of everything. So I'm just going to do this sort of division with the count without the filter. And I'm going to make this a percentage. And so we can actually see, yes, I do have a higher percentage of errors here than I did before at 0.54%. Another way people like to look at this is the inverse. So maybe I want to see a count of success. So I can put the word not and see, the success rate of my system. How many errors am I getting? And you can see these values below 100 are where I'm having some errors. But looks like the system's okay. A couple errors here and there, we can let that slide. Next up, I want to show how you can do the similar type of thing, but rather than using a count of overall records, you can actually divide by some count that's meaningful to you. And let me clear this out, show you some of that data. So if I go back to my metric data, there's this really cool field we have in some of my data that tells me how many requests that I get. So you can see I have this like request count. And unfortunately for me, this data is a counter, and the counter just keeps getting bigger. And so this actually isn't helpful because I'm getting like a growing number, and I want to see how many requests did I get in a specific time range. So this is a good example where you can play with the aggregation options here. And the one I want is differences, because differences will show me the difference between different periods. So you can see I got more requests in this period than I did in this period, just by comparing that big number that's growing. Now that I have the total number of requests that my system served, I can use that to kind of normalize my data. So maybe I want to look at a specific metric and divide it by the number of requests I get to see how many per request did I have. So to do that, I'm going to type in an average of, and I'm going to forget my field name here, system CPU IO weight PCT. Let's do that. You can see I've got all sorts of problems here. I think I actually get autocomplete if I put the division sign in. So I'm going to type system CPU IO weight PCT, and I'm going to divide that by the number of requests I got. This can help normalize the data, not on that overall record sense, but in a meaningful count. So I'm seeing the CPU per request, and this is a measure of efficiency. So if I have a ton of requests and my CPU does not move up as much, then I can see the system is becoming more efficient. Lastly, if I have all this figured out, it might be really interesting for me to see this data in the past. So I'm going to get rid of this efficiency part and just look at the average. And one thing you can do, you can duplicate any metric and have two of them by just dragging and dropping. And I might want to look at the past and the present at the same time. Way to do that, let me do average system CPU. There we are, is another advanced option called a time shift. And this is really cool that I can look at the previous period, for example, the previous 15 minutes, while I'm looking at the 15 minutes from now, all at the same time. And this is nice to see if you do day over day, week over week, year over year, whatever your kind of interval is of interest, you don't have to use 15 minutes. You can basically see how you're comparing to the same time in the past instantly in one time. So some really neat controls and options here. I'm going to jump back over here and we're going to look at some power tools and some cooler things. So this is great, but I have to look at all my data manually. And, it's tricky when you're, looking at all of your data together to know when to look at. So this is where machine learning can really help us out. And we're going to look at anomalies detected by the system and then analyze those. And then we're going to put it all on a dashboard to look at multiple metrics at the same time and multiple data sets at the same time. And you can also forecast the future here. So a lot of cool things you can do with a little bit of machine learning and also heavy use of dashboarding as well. So back over here, let's say I'm good on this one. I move my little zoom controls and I got my dashboard. Again, I don't know if this is the worst time for this metric. So one thing I can do is come over to the machine learning section, and I'm going to throw that away, unfortunately. And I'm going to have an anomaly detection job, which allows me to pick a metric. So for example, that CPU IO weight metric we've been using, and I want to see how it's been performing historically. I can have the machine build a model and then graph anomalies in time to tell me when this value is abnormal. And what's also cool is I can have it break it down by, in this case, because I'm looking at CPU, I have my different hosts. So I can look at somebody like Frank and see when has Frank had abnormal CPU time. And the system will detect time windows where I've had anomalies, things that are above normal. And so this is a really great way to find anomalies without having to actually browse through your data and look for spikes yourself. Really, really powerful. The other thing you can do here is click this forecast button. On this data set, it's not that interesting because it is pretty constant, but you can have it actually predict the future as well. So you can see if you're going to maybe need to scale up in a day. And it gives you this cone shape of time coming off here in the future. So really, really cool. These are the features that are in our Platinum licensing. They require the machine learning licensing, but they're really, really useful to help you, save some time. Now, once you have all this, you might want to put it all in one dashboard. And this is where you can look at like all of your metrics at once and start to draw these like multi-data set correlations. So I'm going to change this and just look at 15 minutes. I have a very small cluster. I'm on a cost savings kind of guy. So here I have all of my different metrics here. I have multiple metrics of the same one we've been looking at for CPU, IO weight, and I also look at things like network bandwidth, how much data is coming in the same visualization. And this can be a really useful tool to help draw some conclusions and root causes. And you also notice as I mouse over these, I can see the same time period in multiple visualizations. So I can really build a visual that gives me all of my metrics in one, so I can start to build comparisons. And this can be across data set. So this bottom graph here is showing me that CPU metric alongside the count of those error logs that we were looking at earlier. And I can see if they're correlating to maybe an increase. And in this case, they are. If you're wondering how this is authored, you can just come into here, edit, and we'll see that I have two panels. So there's this button down here at the bottom where you can add a layer, and that layer can come from a completely different data set. So all you have to do is put your time data in the same place, the horizontal axis in this visualization, and then drag on a different data set. And that's that universal join I was talking about earlier. That's just so powerful. The other thing you can do with machine learning, if you're into it, I think it's a cool way to integrate the machine learning anomalies into the rest of your analysis, is bring on the machine learning data itself. Now, I didn't have any in the last 15 minutes, but if I switch over to a conveniently selected time frame, you can see that I actually did have some anomalies that were detected, and I can do the same thing and overlay that data on top of my existing metric data to see some analysis and maybe draw some conclusions. So this is a really, really cool way to overlay multiple pieces of analysis and to build visualizations that help you understand if things are correlating together in time or not. You can also directly embed the machine learning data visualization alongside as well. So you don't need to be looking back and forth between the two different areas. You can have it all on your dashboard. I like to think of my dashboard as like my workspace, and really, really useful in that regard. Hopefully this was a little bit of a whirlwind tour of the tools and things in Kibana, but maybe you learned something. We also have a lot of great resources for you. And this is a PDF that you're going to get as a takeaway, so you don't have to worry about like trying to type these in, or you can Google them too if you'd like to. But our documentation is very thorough, and we're definitely always out there on our Discuss forum. So if you haven't used that and want to reach out to us, reach out to us, start the conversation at any time. We're here. And I think with that, we're going to take your questions, and as we probably have been throughout the talk, and go from there. Thanks a lot.